Hey Kylie, what do you call a number that can't keep still?
I don't know, what?
A Roman numeral. Chapter 4.8 is quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. This formula is used to solve the equation ax squared plus bx plus c equals 0. Here's an example problem. You subtract both sides by 2, which gives you x squared plus 3x minus 2 equals 0. Then you plug these terms into the quadratic formula, which gives you x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 2 over 2 times 1, which then gives you x equals negative 3 plus or minus the square root of 17 over 2. This then gives you x equals negative 3 plus the square root of 17 divided by 2, which is x equals 0.56, or x equals negative 3 minus the square root of 17 divided by 2, which equals negative 3.56.
So in chapter 5 and lesson 6, we'll review how to find the possible rational zeros of a function. And in our example, this is our example, and so we started with p, which is the constant. P would be the factors of this constant, and then q, which is the factors of the leading coefficient, which in our circumstances is 1. Therefore, the p answers would be 1, 2, 5, and 10, because we remove factors of 10. And then our answers for q, which are factors of the leading coefficient, is just 1. And then in order to find the possible zeros, you must put all of the p's over q. Therefore, we would have everything over 1. 1 over 1, 2 over 1, 5 over 1, and 10 over 1. Therefore, all of our possible zeros are 1, 2, 5, and 10.
Okay, so I had matrices, and a matrix is an array of numbers, and you can add, subtract, multiply, and divide the matrices. And so I'm going to start off with adding matrices. And so this itself is a matrix, and these are the rows and these are the columns. And so how you would add the matrices, you would take this number and add it to this number, which would give you 7. 3 plus 4 is equal to 7. So that's how you get that number. Then 8 plus 0 is equal to 8. So that's how you get that number. You can do the same thing for the bottom, 2. 4 plus 1 is equal to 5. And then 6 minus 9 would give you negative 3. Multiply matrices, and if you look at your section preview, we were given this equation, which says EF plus CF will give you this number here. BE plus DF will give you this number here. AG plus CH will give you this number down here. And lastly, DG plus DH will give you this number here. So I labeled the numbers we were given A, B, C, D, E, F, G, H. So to find this number, you multiply A and E, which is 4 and 3, so that's going to give you 12. And then you add that to C, F, which is going to give you 8. So that together is going to give you 20. And I'm going to write the final answer on the side. Next, to get this number, we multiply DE, which is 0, plus D and F, which is 72. So then this number would be 72. Next, do A and G, which is 16, and you would add it to C and H, which is just 6. So that would end up giving you 22. Lastly, you multiply B and G, which is going to be 0, and you add it to D and H, which is 54. So then your final number would be 52. So the final matrices would be 20, 22, 22, and 54.
Hi, I'm going to teach you all, or remind you all, how to do basic logarithms. So for starters, here's like the starting formula, and this means, or pretty much reads, log base b of the number n is equal to p, the power n is raised to. So I know this might sound confusing, but work with me here. So this is pretty much the exact same thing, except we're going to put in numbers this time. So this reads log of b base 2 is of the number n, which is 8, is equal to p, the power n is raised to, which is 3. And then if you had to write that in exponential form, it would be 2 raised to the third is equal to 8. So whenever you see a logarithm written like this, and then you have to solve, and the 3 isn't there, you're just going to assume, okay, what is 2 raised to get 8? And the answer is 3. So let's drive on over to example lane here. So another one would be log base 4 of the number 64 is raised to the third power, and then the exponential form of that would be 4 raised to the third power is equal to 64. And then also we have 12 raised to the second power, which would equal to 144, and then the log of that would be log 12 of the number 144 is raised to the second power.
So for 5-1, we're going to teach you the properties of exponents, and the first one is product of power. Product of power is when you have two of the same bases with two different exponents and you add the exponents together. So an example is 2 to the third power times 2 to the fourth power. You add 3 and 4, which is 2 to the 7th, which equals 128. The second property is power over power, and that's when you have a base raised to an exponent multiplied by another exponent, and you multiply those exponents together. An example of this is 3 raised to the third power raised to the second power, which is 3 to the sixth power, which is 7 to the 29. The third property is power of a product, which is when you have two different bases by the same exponent, and you would distribute the exponent to each base. So for this example, we multiply 2 to the fourth times 3 to the fourth, which would give us 1,290. The fourth property is power of a negative exponent, which is written as the base multiplied by a negative exponent. And since you can't have negative exponents, the whole equation must be over 1, and a cannot equal 0. So for this example, we would have 7.
Hi, so these are the last three properties of exponents. So the first one is the zero property, and considering that a is any number raised to the 0 power, it's going to equal 1 if a is not 0. For example, negative 16 raised to the 0 power would equal 1, and that's always. So any number you take to the 0 power will always equal 1. So this is kind of just memorization. You can get these by memorization. And then the next one is the quotient of powers, and then any number raised to the n power in fraction form over any number raised to the n power, you subtract the exponents. You take the top one from the bottom one, or you take the bottom one from the top one, you choose a m minus n. And for example, we have 6 raised to the negative 3 power over 6 to the raised to the negative 7th, I mean 6, don't know where I'm reading, equals 6 minus 3, and then you're going to subtract, so always have that subtraction sign, minus negative 6, and then these become an addition sign because two negatives cancel each other out. So negative 3 plus 6 is also to the third power, so then you have to simplify even more, so therefore it is 216. And then the last one is power of a quotient, and that is any number over any other number raised to the n power. And then for these, you're going to distribute this exponent to both your top and bottom, so your numerator and your denominator. So for example, 4 over 7 raised to the second power would be 4 to the second over 7 to the second, and then you simplify and you have 16 over 49. That's all.
Hey, I'm not Allie, I'm Lindsay.
I'm not Lindsay. I'm Allie.
But you're JT.
Money.
Yeah, you are. So the shout out is to John Torres, which also translates to J Money T, JT Money. Throw him up.
It's a moniker.
Yeah. What else do you have to say?
We love you, JT. Thanks for the past 2 years of math, even though we're not the best at math.
Or this, like, Captain Boy House Cody. I'm always getting my hair done. You're eating.
We just want to say good luck on your finals this week. Don't forget to study because your grades do matter. But don't stress too much. You've got this. And have a great summer!